Okay, Chem 1401 practice midterm 1. Let's take a look. So the first question says calculate z to the correct number of significant digits. So the equation is z is equal to 38.70 subtract 37.90 and then multiply the whole thing by 23.7. So the first thing I'm going to do is I'm going to do what's inside the brackets, and I'm going to take 38.70 and I'm going to subtract 37.90. And following the rules for significant digits in subtraction, I end up with a number which is 0.80. So now I only have two sig figs in this number, my 0.80. So then when I insert this number into the equation, z is equal to 0.80 multiplied by 23.7, my final answer should only have two sig figs because I only have two sig figs in this number here. So when I multiply that out, I end up with 19. So if I round that, I end up with 19. And again, two significant figures. So let's move on from there. Question number 2 says you have a 100 mil graduated cylinder and it weighs 115.8 grams. When it's empty, then you put an unknown liquid in it and it weighs 156.5 grams. If the cylinder is filled to the 72.5 milliliter mark, what's the density of the unknown liquid? Well, for this one, I'm going to need the formula. I'm going to need the formula density is equal to mass over volume. And how am I going to get my mass? Okay, well, I know that the mass is going to be equal to the final mass minus the initial mass. And then I have my volume, which is given to me in the question. So to calculate the overall mass, I take the final mass, which is 156.5 grams, and I subtract 115.8 grams. I divide that whole thing by my volume, which is 72.5 milliliters, like that. So if I do a little more of the math, I can see that I end up with 40.7 grams, and I divide that by 72.5 milliliters. And I'm set up because I know the units of density are grams per milliliter. I have three significant figures in my numerator. I have three significant figures in my denominator, and thus my density is equal to 0.561 grams per mil. There we go. I hope that's one of the answers. Yes, it's the first answer. There we go. All right, so let's move on to question number 3. So it says here that the volume of a cube is computed using volume is equal to length cubed. So I have the length multiplied by the length multiplied by the length again. If a cube has a length of 200 decimal picometers, how much is its volume? Well, you can see here the number, if it's 200 and then I have a decimal at the end here. So this tells me I have three significant figures in the length. So how am I going to figure out the volume? Well, if I know the length of one of the sides is 200 picometers and I know this formula for volume, I can just substitute that number in there. So I'm going to put that volume is going to be equal to my 200, don't forget the decimal to indicate the three sig figs, picometers cubed. And when I punch that in my calculator, I end up with 8.00. Again, I've got to have three significant figures multiplied by 10 to the 6th picometers. And don't forget, they're cubed now. So I've cubed not only the number 200, but I've also cubed the picometers. So I have picometers cubed. Now, I want to convert that into meters cubed because you can see that every answer is given in cubic meters. So you might remember that in 1 meter, I have 10 to the 12 picometers. So in order to figure that out in meters, to convert that into meters, I'm just going to put 8.00 times 10 to the 6 picometers cubed. And again, I know that in 1 meter, I have 1 times 10 to the 12 picometers, like that. But in order to get these units to cancel out, the picometers cubed, I have to cube this entire conversion factor here. So when I cube that entire conversion factor, you can see that picometers cubed are going to cancel out with picometers cubed, and I'm going to end up with meters cubed. So when I punch all that into my calculator, I end up with 8.00 times 10 to the negative 30 meters cubed. So is that one of the answers? Yeah, it's this one right here. It's this one right there. There we go. So moving right along, let's take a look at question number 4. So it says here the volume of 14.6 microliters. So these are microliters. This is symbol for micro, is equal to how many nanoliters, picoliters, liters, or centiliters. So I've already done the math on this one, and the conversion factor that I used is that in 14.6 microliters, I know that one microliter contains 1,000 nanoliters, like that. So my microliters are going to cancel out like this, and I end up with 1.46 times 10 to the fourth nanoliters. There we go. So that's the first one here. Okay, let's take a look at question number 5, which deals with nomenclature. It says here, which of the following is tetraphosphorus decoxide? So you can see the elements that are in this compound are phosphorus and oxide, that indicates oxygen. So I have phosphorus, which is a nonmetal, and I also have oxygen, which is a nonmetal. So this is a covalent compound. So based off of the prefixes, I have tetra. So tetra, that indicates 4 phosphoruses. And then I have decoxide, so that indicates that I have 10 oxygen atoms. So that would give me P4O10. So this must be the answer here. All right, good nomenclature practice. So let's move on to question number 6. So you can't see the whole thing here, but I'll kind of help you out here. So a little bit of the question got cut off when I made the slide. It says, how many protons, neutrons, and electrons are there in the neutral, so neutral atom, of strontium-88? So it's strontium-88, so I'll write that down here. So strontium-88. Sorry, that got cut off a little bit there. So strontium-88. So if I look on the periodic table, I can see that strontium is element number 38, and I'm talking about strontium-88. So if it's strontium-38, that tells us right away that strontium has, strontium does have 38 protons because it's element number 38, and the number of protons are what governs the identity of an atom. So I have the number of protons is going to be equal to 38. And this is really important, that it's a neutral atom. So there's no charge. It's not a cation. It's not an anion. So if it's a neutral atom, I'm going to need exactly 38 electrons, which are negatively charged, to balance out the 38 protons, which are positively charged. So my number of electrons is going to be 38. And then it's just kind of a quick back of a napkin calculation to calculate the number of neutrons. And you should know that in order to determine the number of neutrons, I simply take the mass number and I subtract the atomic number. So 88 minus 38, so that gives me a total of 50 neutrons. So that must be this one right here. All right, let's take a look at question number 7. This is sort of a conceptual question. It says, which state of matter has a definite volume but not a definite shape? So this is something that we covered in class. So if you think about a liquid, even if you just think about something like water in a water bottle, it definitely has a volume. So let's say you had 100 milliliters of water, in a bottle, but it doesn't matter what vessel you put that in, the water is always going to take on the shape of that vessel. So a liquid has a definite volume but does not have a definite shape.